All right, so we're looking at section 8.3 for the second part, section 8.3 part 2. I don't think it's turned on. And what we will look at today is another way to find volume of rotation. Okay, we will be looking at solids formed by revolution. And this method that we learned today is useful in some problems that would be difficult to do with a washer or a disc. So we'll look at cylindrical shells, and then we will also look at finding the surface area of a solid. And when we talk about surface area here, we're talking about lateral surface area. So we're ignoring the bottom. Thanks, Sam. I don't know why it's not turned on. So the screen is coming up. It is section 8.3, part 2, so label it that way. Here it comes. That's my comment. What that is, what we're reading. Okay. See, I drew that. Yes, thank you very much. All right. So, volume by cylindrical shell. What we are going to do is use the exploration that they have in the book as an example. We're going to do it a little bit differently than they describe, but it gives us a nice problem to look at. So we have the region enclosed by the x-axis and the parabola. Y equals f of x equals 3x minus x squared. Is revolved without the line x equals -1 to generate a shape of a cake, like a bud cake. So we're taking this parabola, and we are rotating it around. Do I have that on the wrong one? Around the line y equals or x equals -1. Okay, I got 1 over 2. Okay, so can we see how we would get that bud cake? All right, now let's think about this. If we wanted to do this with washers, then we would draw our rectangle palette. Horizontal, okay? And we would need to do right minus left. So we would need to solve y equals 3x minus x squared for x in terms of y. How's that looking? Not so easy, yeah? So there are some functions that are difficult to get into the other variable. And so that is a case where a different method would be helpful. And that method is volume by cylindrical shell. So the differences between disc and washer and shells, number 1, very important, the rectangle is parallel to the axis of rotation. So that's a big difference from what we've been doing. Okay, so that's the first thing we have to know. All right, well, let's think about what we get. If I take my vertical rectangle and I rotate just that one rectangle, am I going to have dx or dy? Dx. If I take that one rectangle and rotate it around the line x equals -1, what do I get? Yeah, a washer kind of, but a very long one, right? A shell. You get a shell. And I think like a soup can with no top and bottom. You get a really thin cylindrical shell. Okay? So then if we were to do that for a whole bunch of rectangles from 0 out to 4 and sum up the volumes of each of those shells, then we would have the volume of our cake. Yes? Okay. So the way that I think about cylindrical shells, can we see those Russian dolls? where you open it up and there's another one inside, another one inside, another one inside. That's kind of what we're doing here with these shells. Okay? That's the girls' version, sorry. That's all I got. All right. So, when I rotate that one rectangle around, you see my shell. I get a shell. And if I break that shell down one, if I just cut it right here and flatten it out, then I have a skinny rectangular prism. Yes? Okay. And what is the thickness of my rectangular prism? Dx. Okay. And we'll call this height here. And what's this length? The circumference. 2 pi r. All right. So if I want to find the volume of one tiny shell, we would call it the differential in the volume, dV. Not the whole volume, it's the volume of one tiny little representative. And how would I find that? How would I find the volume of this solid that we showed here? How do we find the volume of a tissue box? Length times width times height, or 2 pi r h dx. Okay? This is how I start volume by shells every single time. I write this. Or dy. Okay? dx or dy. So now I just need to integrate this thing properly to find my total volume. And I need to figure out what r and h are in terms of x. So I will have the integral. If we look back at our picture, thank you, I'm trying to get there. There it is. So my rectangles will stack left to right from here over to here. So 0 to where? 0 to 3. From 0 to 3. I can bring my 2 pi out in front. All right, so now I need to think about the radius. So with shifts and washers, I told you about how to draw the radius, so let me tell you how to think about the radius for this one. All right, so the second difference from washers and discs is that the radius is drawn from axis to the rectangle. So my radius will be drawn from the axis to the rectangle right here. So now we need to think about how we write that radius in terms of our variables. So what do you think? X plus 1, very nice. The distance from our origin to the rectangle is x. That's going to change all the time. And we will always be adding one more to that. So that is x plus 1. So now we have 2 pi r. What about the height? What's the height of my shell? The function f of x. And what is our function? What is it? 3x? X minus x squared? That is our f of x. Thank you. I think I'm always. Sometimes it will be switched if we are rotating around a horizontal, then f of x will be a radius, and x plus or minus 7 would be the height. Okay, so it could change a little bit, but we're usually dealing with an x value or a y value and an f of x or an f of y. So we have 2 pi RH dx. And then we can integrate this, yes? Quickly do this on your calculator so I can answer. Yes? Let me go back and show you. Question is, where does the x plus 1 come from? I'll show that while you guys are calculating. All right, so see my radius from the axis to the rectangle. Well, the distance from the y-axis to the rectangle will change with every shell, right? And that's going to be x. That distance from here to here is the direct. And then we'll always have that distance from the origin to the axis. So that's where the x. The 2 pi comes from the circumference of, so one shell, when we rotate the rectangle, when we flatten it out, this is the circumference of the shell, pi r. Yeah? Okay. Anything else on this? Give me a solution, please. 22.55. Do we agree? Okay, good. All right. All right. Any question on shells? Okay. I'm going to jump ahead to my surface area example so that we have an example of each before I run out of time again. So we'll come back to number 21 from your homework. Let's talk about surface area. So now we have a solid formed by revolution. We can find their volume. It would also be interesting to know sometimes the actual surface area. This looks like a vase to me, yes? Yeah. Surface area of the vase. Okay? But when we talk about surface area, we're only talking about the lateral surface area, not the top and the bottom. All right. And what I want you to write down to start is the actual formulas, and then I'm going to talk about them on the sideboard, because I describe it a little bit differently than they do. So here are the 2 formulas for surface area, depending on whether you are in X or Y. We have 2 pi times the integral from a to b of f of x times the square root of 1 plus f prime of x squared dx. Only the f prime of x is squared. Or if we are in terms of y, we have 2 pi, the integral from a to b, f of y times the square root of 1 plus f prime of y squared dy. And then my helpful hints are, you are in dx when you are rotating about a horizontal axis, and you are in dy when you're rotating about a vertical axis. Most of these are done with the calculator because they can get pretty ugly. But you will do 1 or 2 by hand, and they can be tricky. The algebra gets a little involved, so we will do one together. But first I want to talk about where this formula comes from, and I'm going to do this on the sideboard. All right, let's move on and look at, I think I chose some directly off your homework. I did. You're doing 55 through 61 odd, and I would like to do, let's start with 61. 55 through 61 odd for that part. So we are going to do 61 together. No, that would be nice, but it's not. That is not all our homework. Okay, so on this one, the directions got cut off. But what we are being asked to find is the surface area of the solid. Says in exercises 55 through 62, find the area of the surface generated by revolving the curve about the indicated axis. So in 61, we have rotation happening around the x-axis. So very quickly graph this so you can see what we're looking at. On your calculators, do it now, please. we're looking at something like that. Verify that for me. We are interested only between 0.5 and 1.5. Right, is that what it looks like? Okay. And we're interested between 0.5 and 1.5. So we end up with a solid that looks something. Oh, I have to draw right now. Something like that. Right? When we rotate that? Alright, so what is our formula for surface area? We're rotating around a horizontal axis. So will I be an X or Y? I'll be an X, I'm drawing in my R. And what is my formula? 2 pi times the integral of what? F of X times square root of 1 plus F prime of X squared, and then our dx is on the outside. And we are interested in going, as we were trying to say, from 0.5 to 1.5. So let's fill in what we have. 2 pi integral 0.5 to 1.5 of what? Square root of 2x minus x squared times square root of 1 plus. So here we're going to get f prime, right? What's our f prime? Here we go. Chain rule. 1/2 2x minus x squared to the negative 1/2 times 2 minus 2x. And that is all under this root.
Is that bar all squared?
And that is all squared. Yes, let me get my parentheses right. Open, close, close, squared. And that is under my root. And then I have my dx. Yeah, this is a 2x. Let's see if I can make that look. All right, it's nasty. So on this one, this is not one we would do by hand. But even with your calculator, this one is tricky. So here's my hint. Y1, square root of 2x minus x squared. Y2, I would do that n deriv, math 8, of y1 with respect to x at every x. Okay, so then when I do my integral, this one would be y1 times the square root of 1 plus y2 squared. You see how helpful that is? Instead of having to type all of that in? Because that prime is actually squared in the formula. So we would have, let me just write it out, 2 pi integral from 0.5 to 1.5 of y1 times square root of 1 plus y2 squared. Yeah, the way I would do it. Okay? 55 is one that we will do by hand. I will go over it in class. Have a good day. Homework's on the assignment sheet. I have your quizzes graded. Did you see? See they're already graded and in?
I didn't see it.
I did it.
And Karen crushed it.
And Linda, I did check homework before you came in. Did you have your homework done? And Sam?
Yes.
Did you do it all?
Yeah, I did it all.
All right, good. Sam, did you do it all?
Logan Shade Green,
Linda?
where she does most of the work with Logan tries to...
Aaron, I didn't check your homework. How much is done?
Logan looks at this.
Got it. Thank you. Joel, you showed me yours. Joel, if you're today. All right. Have a good day.
Tell me and say what we got in the quiz.
Oh, I got it here.
That's a good quiz.
You're right on top. Eat up.
Go ahead, Ken.
It's the areas, you guys. This is fine. It's just your areas that you have some errors in. Anybody else want their quizzes from first period? That's first.
Say, I'll put it on you. It's on me.
Joel and Robin, I got yours. What's that?
Turn it
There were two versions.
Thank you.
One was, Joel? Which one for Robin? Dominic? Ian, if you want. Wrong reading. Yes, good. So, pi 6 on the left, the two functions on the right, would be this one. Your region has pi 6 and that on the left. Does that make sense? Okay? Want yours? Sure. That's one there, not graded. Hold on. Take all three, share them with the neighborhood. That one, thank you. On the whole thing. Good deal. Yes, I did.
How cool. Okay.
You're welcome. Okay. Oh, I think that's actually. Oh, that's right. Ted and Connor?
I wrote it probably recording and then I didn't get on it.
Yeah, it didn't take off. But,
Well, I wrote it probably here. I just wanted you to know that we did it with the calculator.
you don't have to.
Okay.
I don't like that face. This is.
You should give me love with they're wearing different clothes on the side. Profile call? Oh, that's your profile. Oh. I think I'm gonna go. Oh, you come back to 45.
Oh, I see.
It's fine. I'm not gonna get the card until I'll probably get the SIM card sometime before the probably go to the AT&T store.
Quiet, please.
I'm all right. So they will be
Quiet, please. Hey, Rhonda, could you turn off my
NHS says we'll be sponsoring a food drive from January 17th to February 6th. All proceeds will go to the spring camp and grade
Oh, shit.
Junior interviews are taking place now. February 6th. All juniors